2 by 600 megawatt thermal power plant project lies on the right bank of Qingtai River. The project site is about 80 kilometers to the west of Hanoi and about 40 kilometers to the east of Haiphong, the biggest port in North Vietnam. BOT, Build, Operate, Transfer model, is applied for the project by a consortium of CPECC from China and JAKS from Malaysia, which is to invest $1.8685 billion in total. It is a key project among the Belt and Road Initiative, and also it is the biggest overseas investment for CPECC, as well as the largest single investment from China to Vietnam by far. Engineering. Compact arrangement philosophy is adopted in plot planning. The main power block is at the center of the plant, with the fixed end facing the northeast, and a space on the southeast is reserved for extension. Switchyard, cooling towers, main power block, reserved space for FGD, limestone yard, and coal yard are arranged from east to west in a streamlined manner. Ancillary facilities are placed immediately to the north of the main power block, and the administration building is located in the northeast part of the project site. The outgoing lines of 220 kV and 110 kV are connected to the power grid via the switchyard in the east of the plant. Fuel coal for the project arrives at the site by water and unloaded at the coal jetty dedicated for the power plant, and then transported by belt conveyor to 2 strip coal yards in the western part of the plant. Long-span grid structure is employed for the dry coal shed of the coal yard, and wind breaking and dust suppression wall is set up all around the coal yard. To minimize the impact on the local environment, there are 3 bucket wheel stacker reclaimers. Fuel coal is transported through on-site transfer station to Coal Bunker Bay in main power building. Valley-type dry ash yard is located in the area designated by the Vietnam authorities. The maximum height of ash heap is about 30 meters. The ash heap will be increased and secured by damming, and the ash shall be heaped from the dam to the tail of the ash yard. It is transported from the plant to the ash yard by tube conveyor, and then it is transferred to planned area for compaction and storage in the ash yard. Also, an ash transport road is set from the plant to the ash yard for emergency. The design of architecture and landscape in the project mainly embodies the corporate culture of the owner, considering the combination of the unique culture of Vietnam. To forge a symbolic architectural style and to implement the philosophy of building a resource-saving and environment-friendly company. And the design shall also give emphasis to people orientation and to make it neat and beautiful, incorporating the features of modern industrial architecture. For the 3 main equipments, the technology of the 300 megawatt CFB boiler is introduced from Foster Wheeler. The 600 megawatt subcritical steam turbine is equipped with 9 stages of steam extraction for the first time, and the 600 megawatt hydrogen-cooled generator, hence a 2-on-1 configuration is adopted, with 2 300 megawatt boilers serving 1 600 megawatt turbo generator set. Innovative steam-cooled cyclone and its connecting duct is employed for anthracite by Foster Wheeler, and proprietary and patented technology is utilized to regulate the temperature of the reheat steam, and also high-temperature expansion joint is cancelled. Every pair of the 4 boilers on 1 turbo generator set is arranged symmetrically, and the routing of critical power piping is optimized. To reduce the pressure loss of the piping system of the 2-on-1 units, circular flue gas duct is employed downstream ESP for more compact and reasonable arrangement. Globally advanced aerodynamic design concept is adopted for the turbo generator set. Through the application of 3D visualized design and analysis technology, low-pressure aerodynamic performance is optimized. Internal leakage of new 360-degree volute-type LP cylinder is reduced, and steam admission pressure loss is decreased. The 3-cylinder and 4-exhaust turbine is equipped with 9 stages of steam extraction to form high-efficient thermodynamic system. 3 HP heaters plus 1 deaerator plus 5 LP heaters. Compared to 8-stage heat regenerative system, heat rate of steam turbine drops by 20 kJ per kilowatt hour, which contributes a gains of $10.15 million over the whole life cycle of the project. In the engineering of civil structure, more reliable and convenient PHC pile is selected to combat the specific geological conditions of soil liquefaction tendency. Meanwhile, according to seismic design requirements and construction conditions in Vietnam, steel structure is adopted for major buildings. Members of the structure will be shop fabricated by professional Chinese steel structure manufacturer and then be transported by water and delivered to site for erection. Considering the tropical rain climate featuring high humidity, high temperature, and plentiful of rain, as well as the characteristics of the water supply system, expanded unit-wise system with mechanical draft cooling towers is finally selected for the water supply system of the project. At the same time, with the optimization of the general layout, the combination of pipeworks and ditches is adopted for the plant rainwater drainage system. The pipeworks are shop fabricated locally and transported directly to site for erection, so as to ensure quality and shorten construction time. Centralized control is adopted for the boilers, turbines, and generators of the project, and the central control room is placed on the operating floor of the turbine house. The wall of the control room is equipped with 42 pieces of 46-inch LCD screens, which are beautiful and useful. Plant performance indexes comply strictly with the requirements by the EPC contract of the project. Pollutant emissions, noise levels, and other environmental emissions indexes are in full compliance with local laws and regulations in Vietnam, besides meeting the requirements by the EPC contract. Project management. On February 28, 2017, the project is officially started. The preparation of temporary works and construction utilities, as well as bidding and procurement of equipment, were in full swing at the same time. Temporary living quarters and offices are arranged on the east side of the plant site, which mainly include office area for managing personnel and living quarters for the staff. The temporary works for construction is arranged on the south of the main plant area, which mainly include various engineering offices, equipment assembling fields, equipment custody area, etc. The wharf construction area is arranged along the King Tay River. Temporary water intake pump house is set at the wharf side, and a secondary pump house is also set in the plant site to supply construction water. The planned capacity for construction power is 6,300 kilovolt amps. The power supply derives from the 35 kilovolt line to the local grid. The construction of roads shall consider both permanent and temporary needs. The temporary ones shall connect with permanent ones to facilitate smooth transportation. The bidding and procurement of equipment, materials, and services are conducted on the Energy China Electronic Procurement Platform. Logistics are mainly carried out by maritime transportation. The port of exit is Shanghai in China, and the port of entry is Haiphong in Vietnam. The whole process is monitored by big data, as the overburden of the plant area is composed of silt, sand, and pebbles formed by alluvial and proluvial. The groundwater table is shallow, and the geological conditions are complicated according to the design requirements. The project site was backfilled by blowing sand and ground treatment methods such as dewatering by band drains, preloading, gravel piles, cement mixing piles, jet grouting piles, etc. were all applied. On March 1, 2017, the construction of equipment's unloading jetty and its road was commenced. In July 2017, the heavy haul roads were opened to traffic, and in August 2017, ring road network in the plant area was formed to meet the requirements of heavy haul transportation. On June 1, 2017, the construction of the shaft of the stack commenced. On November 16, 2017, the first tank of MPB foundation concrete was poured, and the erection of the major underground pipe net was in full swing. On November 13, 2017, the foundation work of the boiler was completed. On December 26, 2017, the construction of the stack shaft was finished and the erection of its inner tubes started. The height of the stacks is 170 meters and the shaft was constructed using turnover formwork. On January 14, 2018, the foundation work of the main power building was completed and the erection of its steel structure was commenced. On May 1, 2018, the foundation work of the water treatment area was finished and the erection of its superstructure was started. On July 19, 2018, the erection of mechanical draft cooling towers will commence. On August 11, 2018, the erection of boiler drum will begin. The drum will be hoisted by hydraulic lifting devices to 52 meters height and then fixed with the suspenders. On September 30, 2018, the top of the main power building will be sealed, and the steel roof truss will be shop fabricated and delivered to site and erected by power crane. and then the main power building will be enclosed, which turns on the erection work of the process system across the board. On October 15, 2018, turbine erection of Unit 1 will be kicked off. The stator of the generator will be hoisted and erected by double EOT cranes. On January 4, 2019, the erection work of the process system in the water treatment area will be completed. On April 30, 2020, trial run of Unit 1 as a whole will be started. On May 14, 2020, the initial synchronization of the unit with the power grid will be completed. On July 12, 2020, reliability run of the unit will be finished. On July 13, 2020, performance tests of the unit will be commenced and completed on August 11, 2020. On August 28, 2020, the unit will be provisionally accepted. On October 28, 2020, and the unit will be provisionally accepted on February 28, 2021. After the COD of the Haiduang 2x600 megawatt thermal power plant project, it will become the thermal power plant with the largest installed capacity in Vietnam. Globally advanced CFB boilers and turbo generator sets were selected. Annual utilization hours, 6,500 hours, and the annual power generation will be 7,596 gigawatts per hour, which gives a direct economic benefit of $37.5 million per year. The project is close to the power load center of northern Vietnam. It can meet the growing power demands in Haiduang, Hanoi, and their surrounding regions. The project can also reduce power transmission distance and line losses and improve the power supply reliability and safety across the region and even for the whole power grid. The construction of the project will improve the generation mix in Vietnamese power system and promote the power supply capability of the grid in dry season. It will powerfully support the social and economic development in Vietnam.